Here we begin to study systems of linear equations. To be able to work on systems of linear equations, we have to understand some basic features of linear equations. Don't forget, every non-vertical line has an equation of the form y equals mx plus b, where y is your output variable, m is your slope, x is your input variable, and b is the y-coordinate of the y-intercept. Let's see a typical motivating example for why people study systems of linear equations. So in this scenario, Aubrey's been offered two job offers. She just finished at Brookdale, and she's been offered a job with the ABC company with a starting salary of $45,000 and a $3,500 raise each year. The XYZ company is offering her a starting salary of $53,000, which is more, but with a lower raise each year, specifically $2,700 each year. Pretend you are Aubrey's friend and she wants your advice. Do you think she should take work with the ABC company or take work with the XYZ company based on those two salary structures? Assume everything else about the two companies is exactly the same. So which one would you suggest she take? Which job and why? Well, to be able to formally analyze this situation, we need to create algebraic models, or i.e. input-output rules that represent these salary structures. So the input variable in this situation is the number of years, and we'll use X to represent that Aubrey will work for each company, and the output variable Y is the amount of money she makes in that year. And X equals 0 specifically corresponds with her starting salary. So let's see if we can cook up an equation for the ABC company. Well, her salary Y will equal, she's starting with the ABC company, she's starting with 45,000, and then you're adding on each year 3,500. So over X years, she'll add on 3,500 X. Notice this equation is technically of y equals mx plus b form. Y equals, the 45,000 is technically the b plus mx. And if you're not comfortable with having it written as b plus mx, you could rewrite the equation as y equals 3,500 x plus 45,000. This equation right here tells us the relationship between the number of years Aubrey's been working at the company, specifically the ABC company, and her corresponding salary that year. Let's do the same thing with the XYZ company. Her salary Y is going to equal, technically she starts out with 53,000, but just because a lot of people are more comfortable seeing this in the back, I'm going to put the 53,000 back there, and then you're going to add on, she's going to get an additional $2,700 each year. So if she works for X years, she'll get an additional 2,700 times X. This right here is the ABC equation for how many years she's worked at the ABC company and the corresponding salary. And this right here is the equation for her salary at the XYZ company after working X years. So we want to understand a relationship between these two equations. Here you can see I've already provided you with a graph. The red line here is the graph of y equals 53,000 plus 2,700x. Technically that is the XYZ company. And the y equals 45,000 plus 3,500x is the blue line here. That's the ABC company. Now let me ask you the initial question again. Which of the two jobs would you recommend that Aubrey take? Well, looking at this graph, you might see there's a point at which she would make the same amount of money. And that happens right here. Same amount of money at ABC as she would at XYZ. I've already done this computation, but this is precisely at an X value of 10, and the corresponding Y value is 80,000. So the meaning of this is in year 10, if Aubrey is at ABC company, she'll make 80,000. If in year 10, if she's at the XYZ company, she'll also make $80,000. So notice, prior to the 10th year, the XYZ company, which is the red line, she's making more money. But then after 10 years, the blue line is higher, meaning she'd make more money with the ABC company after 10 years. This point at which they are the same is what we call the solution to the system of linear equations. So this is the solution to our system. So the solution is the intersection point of the two lines. And the notation we typically use to represent a system is this. You've got this little bracket, and then you just list the two equations involved. So if you want to answer the initial question for Aubrey, which one of the two jobs should she take, it's really important to find the intersection point here. Because as we said, to the left of 10, the XYZ company, the red line, she'd make more money with them. When she works more than 10 years, she'd make more money with ABC because the blue line is higher there. So it's really dependent on understanding this point where they intersect. That is why we call the intersection point the solution to the system. So this system right here, y equals 53,000 plus 2,700x, along with y equals 45,000 plus 3,500x, specifically has the solution 10, 80,000. We will now learn to solve systems of linear equations in three ways. They are the graphing method, the substitution method, and the elimination method. The graphing method is what you saw here, except I already gave you the graph and the solution. So we're going to figure out how to do that without that information already provided. And then the substitution and elimination methods are both algebraic methods. And each of these three methods has their strengths and their weaknesses, and you will see each of these three methods in the coming videos.